All right, great. Thanks, everybody. So your topics for this week are ellipses and hyperbolas. You looked at circles last week, so we're going to do a quick review of circles to make sure we're all on the same page with that, and then talk about how some of those same skills will apply this week with ellipses too. So the standard form for the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. The two characteristics we can identify from this are the center, it's at the ordered pair hk.
Are you sharing your screen already?
I need to stop it so I can start it again, sorry.
It's all good. Thank you.
So, should be coming back in just a second.
There we go.
All right, cool. So the center's at the ordered pair hk. The radius is r. But just keep in mind to remember that r squared is what's in the equation. So when we're calculating r, we should square root it. That's, again, all that was from last week. That was when you had your conversation about circles during class. There's a fair bit of overlap from some of that information to what you'll see this week with ellipses. And one of the biggest overlapping components deals with completing the square. So we'll review that in just a second. Just to have a shot at a specific problem first, let's identify the center and radius of this circle, and we'll also create the graph together as well. So take a second, if you will, and either jot down or either just maybe mentally identify the ordered pair for the center and the value of r for the radius. So the center is at the opposite of the value you see with x and the opposite of the value you see with y. So negative 7, 5 is the center here. Let's see if I can move that. And the radius is the square root of 49, which is 7. So what that tells us, though, knowing that the radius is 7, we'd like to get a few more points on the graph so that we can use those to connect the dots and make the graph. We'll travel left, right, up, and down 7 units from the center. So right 7, down 7, up 7, 4, 5, somewhere about there, and then left 7, 1, 2, 3, 4, 5, 6. So somewhere maybe right over there, and then we'll connect the dots to make the graph. So that's the idea. Use the center and then identify some other points along the circle so that we can use those to make the graph. Questions about what we did there, how we did it? The good news is that creating the graphs for the ellipses isn't all that much different from what we just did with the circle. It's just a little bit of counting. All right. The second task I mentioned just a minute ago was completing the square. We're going to complete the square with the circle here as well. This is the equation of a circle. We'll review that so that we can practice it when we get to the ellipse and need to complete the square there. So the task for completing the square says we're going to group these terms into a group of x's and a group of y's. And what we're going to do within the group of x's is add a new term. We're also going to add a new term to the group of y's. And we're going to add those same terms to the right side as well, the right side of the equation. How we find the new terms to add is by looking at the middle coefficient for each group. In the case of the x's, the middle coefficient is -4. We take half of it and square it. Half of -4 is -2, and -2 squared is +4. For the y's, we repeat that process. Half of 2 is 1. 1 squared is 1. And the whole point of adding that new term is so that now the group of x's is a perfect square. The group of y's is also a perfect square. And then we can combine like terms, we can combine the numbers on the right side to get 16. But now this equation is in standard form, which makes it pretty easy, pretty quick to identify the center and radius. The centers add the opposite of the value with x and the opposite of the value with y. The radius is the square root of the number on the right side. Questions about how we got there? Again, just like before and just like always, we can use the center and radius to create the graph. 2, -1 is our center. We go left, right, up, and down 4. We can get additional points on the graph. Whoops, not there. Stephen, you can add anything in the world you want to add to an equation. As long as you add it to both sides, it's perfectly fine. The only requirement is that it must be added to both sides. Right, if you needed to solve the equation x minus 6 equals 5, to solve it, you would say, oh, I should add 6 to both sides. We're doing the same thing here. It's just that we're not solving anything. But we can still add any number we want to add. Oh, okay, yeah, to both sides, yeah. So 4 on the left, 4 on the right, 1 on the left, 1 on the right. Kind of gets hidden in that graph, maybe. Sorry about that. Other questions about that one? If not, I'm going to give you some time to try completing the square with this one. It's another circle. Both of these are still circles. We'll talk through this one in just a moment, but I want to give you a shot at give you some time to have a shot at it first. So, to the group of x's, we need to add a new term. To the group of y's, we need to add a new term as well. Whatever we add on the left side of the equation, we are obligated to add on the right side. To figure out the new term for the x's, we'll take half of 10, which is 5, and square it to get 25. For the y's, half of -4 is -2. Square that to get 4. which now creates a perfect square for the x's, x plus 5 squared. It's a perfect square for the y's, y minus 2 squared. And on the right side, we get 44. The equation of the circle is now in standard form, so we can identify the center and radius. The center is negative 5, 2, the opposite of the number with x and the opposite of the number with y. The radius is the square root of the number on the right side. The square root of 44 is 2 times the square root of 11. We're going to create the graph, so I'm going to get an approximate answer for that. 2 times the square root of 11 is 6.6. Approximately 6.6. So to create the graph, we would first plot the center, negative 5, 2. Oops, sorry. Negative 5, 2. And then go up, down, left, and right, 6.6. And last one, 1, 2, 3, 4, 5, 6. So kind of over there. Questions about any of those circles or about completing the square? Similar skills are going to come up with the ellipses when we start looking at those next. Okay, so the standard form for the equation of an ellipse is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Just like with the circle, the center for the ellipse is at the ordered pair hk. And what we use the values of a and b for are to determine how far left, right, and up and down we should go. With a circle, we used the radius to determine how far left, right, up, and down we should go. Those were all the same. For an ellipse, they're not all the same. So we're going to go left and right according to A. We're going to go up and down according to B. So not the actual numbers you see in the denominators, but the square roots of them, right? The number in the denominator for x will be a squared. The denominator in the y's would be b squared. So we would have to square root them to figure out how far left, right, and then up and down to go. So let's walk through this one together. The center is at the opposite of the number with x and the opposite of the number with y. That's 2, negative 1. We should go left and right according to the denominator with x, right? Those are the left and right values. The square root of 4 says we're going to go left and right 2 units. We'll go up and down from the center according to the denominator with y. That denominator is 9, and the square root of 9 says we're going to go up and down 3 units. Again, all of those always in relation to the center. So we have a center at 2, negative 1. From there, we're going to go left and right 2 units. And we'll go up and down 3. Once we identify all of those points, we can connect the dots, and that'll be the ellipse. So still pretty similar to a circle, just, maybe different, or certainly would be different distances left and right versus up and down, but otherwise the same process. Questions about that one? Okay, I'm going to scoot it up and jot down the next one. What I'd like for you to do, I'll give you a second to identify the center and then how far left, right, how far left and right we should go and how far up and down we should go. So the center is at the opposite of the number with x and the opposite of the number with y. In this case, that's -1, -3. Left and right would use the square root of 25, which is 5. Up and down, we'll use the square root of 49, which is 7. So -1, -3 for the center. Left and right, 5. 4, 5. And over here. Up and down, 7. And then we'll connect the dots to generate our graph. Questions there? Okay, we'll try one more of these, and I'll give you some time to go from beginning to end. So identify the characteristics and then also create the graph. So the opposite of the value with x and the opposite of the value with y give us the center. Yeah, I agree with all of those, Stephen. So -3, 4. I can follow these lines. -3, 4. Left, right, we'll use the square root of 64, which is 8. So 1, 2, 3, 4, 5, 6, 7, 8. And we'll be at -11 over here. Up and down, we use the square root of 16, which is 4. So we'll be go up and down 4. I'll put us up at 8. And then connect the dots. Whoops, missed that one. Questions there? Okay, so what if this, all those were in standard form. If the equation's given and it's not in standard form, that's just as well. We need to complete the square, but after that it's the exact same as what we did already with the x with the circles. So let's have a look at this one. X squared plus 2x plus 2y squared minus 20y equals -43. What we need to do is add a new term to the group of x's and a new term to the group of y's, but in order to complete the square, we should first factor out a 2 from both of the y terms. We cannot complete the square. In order to complete the square, the coefficient for the squared term has to be 1. Currently it's 2. So our first step is to factor out a 2 from both of the y's. To the x's, we'll take half of 2, which is 1, and square that to get still 1. For the y's, half of -10 is -5. Square that to get 25. We need, whatever we add to the left side, we have to also add to the right side. To the group of x's, we added 1. But to the group of y's, we added 50. We wrote a 25 in the blank, right? The number that's in the blank is 25. But since there's a 2 in front of it, it's instead of parentheses with the 2 in front of it, that when you see 25, it's really a 50 on the left side. So we should add 50 on the right side as well. That gives us two perfect squares, x plus 1 squared plus 2 times y minus 5 is equal to 8. In every case, to complete the x and y term, the coefficient for the squared term has to be 1. So whatever the number is in front of the squared terms, you factor it out if it's something else other than 1. Okay. So this equation is not in standard form yet. We've completed the squares. Those are cool. But it's not in standard form. Standard form for the equation of an ellipse has a 1 on the right side. Currently, we've got an 8. To turn the 8 we have into the 1 we need, we should divide everything by 8. That gives us the standard form equation of x squared plus 1 over 8 plus y minus 5 squared over 4 is equal to 1. From here, we can identify the center, negative 1, 5. Left and right will go the square root of 8. I'm going to get an approximate answer there, just that'll be a little better for the graph. That's approximately 2.8. Up and down we'll do the square root of 4, which is 2. So negative 1, 5 for the center, and then up and down 2, I'll do those next. Then left and right 2.8. To get the ellipse. Questions about that one? Okay. I will actually leave it where it is. I'm going to write down another one and give you a second or some time to complete the square with this one. X squared plus 8x plus 3y squared minus 6y is equal to negative 7. So have a shot at completing the square in order to put the equation in standard form. We'll check that together in a second and create the graph together as well. Of course, if you want to create the graph, feel free to go ahead and do that. So to complete the square with the x's and with the y's, what we'll do is add a new term to the group of x's. We'll also add a new term to the group of y's, but in order to figure out the term, we first should factor out a 3 from the y squared term and the y term. Whatever the numbers are that we're going to add to the left side, we should add the same ones to the right side. For the x's, half of 8 is 4, 4 squared is 16. For the y's, half of 2 is 1, 1 squared is 1. We truly did add 16 to the x's, but to the y's we actually added 3, so that's what we should put on the right side. We now have a perfect square on the left side for the x's, a perfect square on the right side with the y's. I'm sorry, we have a perfect square for the x's and a perfect square for the y's. On the right side we have 12. Negative 7 plus 19 is 12. To place this in standard form, though, we need the 12. We need a 1 on the right side, so that means we should divide everything by 12. And that gives us x plus 4 squared over 12 plus y minus 1 squared over 4 is equal to 1. From there, we can use that equation to identify the center, how far left and right we should go, and then how far up and down we should go from the center to get to the other points on the ellipse. The center is at negative 4, 1. Up and down we'll go the square root of 4, which is 2. Up and down we'll go the square root of 12. We'll get an approximate answer there. Just that'll be a little more helpful for the graph, and the square root of 12 is about 3.5. So negative 4, 1. Left and right 3.5. Up and down 2. Questions about that one? So let's look at, we'll do one more for completing the square. This one's a little, the hardest of the ones we've done. There's more, we have to actually factor out a number from the x's and the y's both. So 9x squared minus 36x plus 4y squared plus 8y equals negative 31. Give you some time to work on completing the square there. We'll talk about it together, of course, in a couple minutes. If you have questions while you're working, let me know that too. So for the x's, we should factor out a 9. For the y's, we should factor out a 4. For the x's, half of 4 is 2, and 2 squared is 4. For the y's, half of 2 is 1, and 1 squared is 1. What we really added to the x's, though, is 9 times 4, which is 36. What we really added to the y's is 4 times 1, which is 4. That gives us 9 times x minus 2 squared for the x's, 4 times y minus 1 squared for the y's, and it's equal to 9 on the right side. We need it to be equal to 1, so to make that happen, we'll divide everything by 9, which gives us x minus 2 squared over 1 plus y minus 1 squared over 9/4, and it's equal to 1. Instead of having, so technically for the y's, we have 4 times y minus 1 squared over 9. I don't want the 4 in the numerator. I want everything. I want all the coefficients in the denominator. So I'd like to move the 4 down there, and how that works is we would write the 9/4 like I've got. So think about what would happen if we actually divided y minus 1 squared by 9/4. To divide by a fraction, that's the same thing as multiplying by the reciprocal of the fraction, which would give us back 4 times y minus 1 squared over 9. Just it's totally cool. It's mathematically sound what I've done writing it as 9/4. But the reason I'm doing that is because to figure out how far up and down we should travel, we would look at the number in the denominator. But it needs to, so if we didn't write the 9/4, what we would be looking at in the denominator is not technically the correct number. That makes sense. If we just left it as a 9 with the 4 in the top, the 9's not correct. The 9's not what tells us how far left and right to go. So for the center, that's 2, 1. Left and right, square root of 1 is 1. Up and down, the square root of 9/4 is 3/2, which is 1.5. So 2, 1. Left and right 1. Up and down 1.5. Questions about that one? So we're going to do one more then. This one's a little different from all of the rest of these. What we'll do with this one is actually start with a graph and write its equation from there. So what if we were given this graph and asked to come up with the equation of it? What we would do is start with the generic equation, x minus h squared over a squared plus y minus k squared over b squared equals 1. And we need to identify the values for h, k, a, and b. Well, h and k come from the center. The center here is at 4, 1. So we can plug in 4 for h and 4 for k, or 1 for k, sorry. A tells us how far from the center we should go left and right. In the case of this ellipse, we're going 2 units to the left, 2 units to the right. They should match. They do. But what goes in the denominator is the square of 2, which is 4. B tells us how far from the center to go up and down. 1, 2, 3, 1, 2, 3. We're going up and down 3. The square of that, though, is 9, and that's what goes in the denominator. So if you're writing the equation from a graph, it's just a bunch of counting. There's no calculations. The one thing we do is square the A and B values, but it's mostly just counting, which is kind of good. But that's a type of question you'll see this week too. Questions about that one or about anything else we've done it? Because that actually covers everything that I've got planned. Normally, we have about 30 minutes for questions. Today we have about 40. Didn't take up the full hour on my part. But I did put the second survey link in the chat. It's the same questions, of course, as always, the same questions from the beginning of the day. If you would complete that survey for me before you leave, that would be really cool. I would appreciate it a lot. But what we'll do with our remaining 40 minutes is answer any questions you have about anything you've got going on. Could be from today or could be anything else you've got in the class. Of course, feel free to stay as long as you want. If you don't have any questions, obviously you're free to go when you get ready. But I do request that you complete the survey before you leave. But any questions you have the rest of our time is for you. You're welcome. Thanks for coming.